Yes. Keep silence now. So in 2 minutes session will stop. Okay. So maintain silence. Listen to the session.
రాత్రి ఎత్తుకుంటావా టీచర్ మధ్య టీచర్
Now can you hear me? So what I thought, if I continue the same subject, you will get bored. So for some time that too after lunch, sleepy time, correct? Yes, very good. You are honest. So I thought we'll take slightly deviate and come back. Okay, that is better I thought. So what I am going to tell you is, okay, this is mainly meant for people who join this program.
లింక్
ప్లేస్మెంట్ వాళ్ళు కట్ చేస్తారు చెక్ చేస్తాను కట్ అయిందంటే చెప్తున్నాను ఇన్ఫర్మేషన్
కట్ అయిందంటే నేను కనెక్ట్ చేసి కాల్ చేస్తాను.
So here what we will do is just because you all it's like
సిస్టంలో బాగా you want to table be
you will all move to some job now from here. You will, some of you may start your own companies or this also have a good lunch. Okay, so you may start your own or you may go to some companies. Okay, there how to be. So that is the transition. You are right now as a student. From here you are transitioning and going to become an employee. Suppose within 2 years more. Okay. So how you have to be prepared? What is the how you have to be prepared? And what is the different environment that you are going to face? This is what I am trying to tell you and how to be prepared for it. Okay. Slide change here. Here I got from classroom to clean room. You may be thinking classroom is fine, understood. From here clean room because space labs are assembled in a facility called clean room. So when you are going from studies to real thing, what is it that you have to be prepared for? So first, what is the transition when you are doing? All along, okay, student to an employee, that is one part. But what does it mean? From dependent to independent, all along you are dependent. Right? Your fee has to pay for your parents or whoever, maybe chief minister will pay in your mother's account and that may come here. All that, but still you are dependent on somebody. Okay. And for anything, you want to buy one pen also, somebody has to give you money or permit you, then only you can buy all that. But once you become employee and you are earning your own, you are becoming slightly independent. Receive to transmit. All along I am telling and you are absorbing. Classroom also same, no? Teachers are teaching and you are learning. But when you go to a job, you have to transmit. You have to give something to the organization whoever is paying your service. Right? So all along you are in receiving mode, now you are becoming a transmitter. Okay. So that is another difference. And knowledge gap. One first the gap is despite all that you study, when you join a job, you suddenly feel that people around you, some people who are lost all their day like this, they are all around you. So you feel that they know so much, I don't know anything. Okay. So that is true for everybody, whoever it is. It will happen. So you need not get hurt up with that. You should, theory to practice. Most of the time, okay, now because of MEP and all, we are doing some practice things, but still there is a lot of difference between what to do in a college versus what you have to do in an office. Okay, so then there is going to be a clear difference. And teacher versus boss. No matter whatever teacher has told you and all that, still they have your interest in their mind. Because if you get them, they will also be happy. So teacher are always like your parents only. They have your interest in mind and all. But when it comes to office, maybe if you are lucky, you may get a good boss. But otherwise, boss is different. No? He is expecting something from you. If you give the output only, he can also show to his boss. And get like that. So there is a lot of difference between a teacher and a boss. Teacher, no matter what he scores, stands like that and sees that you are on secret. But it is all for your own good. Okay? So they are always keeping your welfare in mind. They just like your parents' extension in the college is your teacher. It's no more like that. So don't expect like your father or mother or like teacher, whatever freedom you have, similar freedom you will have with your boss. No. Okay. There will be exceptions. Somebody like me may be there. That is different. Okay. But generally that is the thing. Like in that three idiots, no, natural virus, so on. And friends versus colleagues. Here you are always with friends of your age. You are always with your, except for one teacher when he teaches. Otherwise, you are always dealing with your things. Whereas when you go to office, a person double your age, maybe your subordinate. He may be your helper or your assistant. If you become an engineer, you may have some assistant who is double your age. Or nowadays, young kids have become startups, no? They are starting and he may be younger than you and he will be your boss. He will be the CEO. Both you should be able to absorb and adjust. Okay? You think that this fellow is elder and you have to get work from him. Like that, the younger fellow, you have to take orders from him. Both these situations are possible. Some smokes. And self versus organization. All along you are working for what? When you come to college and work, you are working for whom? What means study or whatever you are doing. This is for your own good. Right? All along you are working for yourself. But once you join office, you are working for the office or the organization. I am there, I am working for this. So somebody, like your teacher will take, he is working for the college. So like that. So that is a major difference. Whatever you do is directly benefiting you now. But in sport, it will not be so. Only thing you will is your salary. And anarchical hierarchy. Right now, hostels and all, the moment power goes, everybody comes out, yeah, like that. We used to wait for power cut, especially tomorrow is exam. We have to study. Okay. So if I am not studying, it is my fault. But power goes, it's not my fault. No. Oh, like that, everyone used to come out of engineering college. Okay. Now anyway, inverters are there, generators are there. You may not have, I don't know what is your situation. So like that. And hostels also, you can jump the wall and come if you security is not catching or dog is not. That is all different. But office is not like that. No such freedom, no such things. There are security guards everywhere. So anarchy to hierarchy. Here and it's a well-laid structure office. Who is the CEO? Next in that group. It's a well-defined structure and it's like that. And hostels versus farms. See here you are staying hostels. That's altogether different. I remember our hostel, right? It's much. I always enjoy. That's why I told Baba. Whereas in employee, suppose in quarters, the discipline is different. Whatever you do in hostel, you cannot do in quarters. Okay. So that is another difference. So there is a lot of difference. So much of transition happens when you are becoming from a student to a. This you will not read in any books. This is purely out of my own experience. People. I have from my own thoughts, not from any book or anything. So I have made these things. So it will help you also because if you are prepared for anything, anything is okay. If you are without preparing, no. So I am just trying to give you an outline of those things. Okay. Generally, new entrants, when you join office, what you expect? Everybody wants to work in design and analysis areas. Though there are so many things, but everybody somehow that is even we were young when we joined. Everybody tells which is your favorite subject? Microprocessor. Our time. Now all AI and ML. Okay. Or data science. Like that. So we are going with the crowd. No? So that is there. And to do something new, you want to do something. Everybody wants to be in R&D and do something new, something you want to find yourself like that. Okay. And recognition, appreciation, awards that you want. Who doesn't want? Everybody wants. Even now, if you do Shah Rukh Khan one more award, you will definitely take. If you think that Oscar has not come to me, it has to come. Why it has come to the roof first? So like that. Okay. Then career growth, promotions, higher position, additional response. Like this are foreign trips, whatever is there. These are what everybody who joins an organization will be expecting from the organization. But what office wants, or the boss wants. Office has not paid you to keep you happy or to give you promotion. That is not the primary thing. They have some expectations from you. One is professionalism. You have to be professional in whatever you do. It should meet certain standards, and you have to be meeting them. And initiative. You should show the initiative. Nobody will tell you you do this. Here you are given a timetable, tested, all that like that. Here you have to show what you want to do, where you can add, so that will be appreciated. And responsibility, you should take responsibility for your work and you have to deliver. Resourcefulness and capability find not those routine solutions. And loyalty. Here people, if you write examination and score right correctly, whatever loyal or not, you will get your marks, everything. Office, it is not so. First, you have to be loyal to the organization. You cannot criticize your office in public. You should not like that. So many conditions will be there. And ability to work as a team member. Now you can do yourself. Whatever you want, you study, you go and write. Nobody will object. But on office, you have to work along with so many other people. Okay. If you are going to fight with them or something, then you are not going to be staying there for long. And bosses can forgive mistakes, but if you like, you are not. So here, anytime you come to class late, if they ask you, and that's something stomach pain or this pain or my sister was not well, brother. All that you can tell her. This kind of excuses do not work in office. Okay? Once or twice, okay, we 2 times, then people will understand. Where you can make difference, then how you can make difference. So see, otherwise, there are so many people, you are an youngster, you join. So how you can create an impact in the office? When you bring in new ideas and new concepts, something is routinely or whatever, in a certain way is happening, you bring in something new. Okay, that will be definitely appreciated. Ease with the latest tools. You see, we are all older. We will not be able to know, but you are having so many tools now. AI tools are there, so many tools are there. I can't use ChatGPT, okay? But you can write any program you want, you can use ChatGPT. So there are tools, similar in engineering, electronics design, if you take CAD, CAM tools are there, machine, in mechanical engineering, electrical, everywhere. Circuit analysis, spice, like that, different tools are there. So because you are having the latest technology and the latest this one, which your seniors may not be having because they have not studied it. It is evolving as we are working, we are going to study. So there is a lot of difference between your studying and using a tool. So that is where you can definitely make an impression. So as you are growing, now I say attentiveness is very high, despite this being post-station, because this is preparing you for future now. Good. See, everywhere that selfishness is there in human being, not just human being, animal, every animal also. The instinct is there to survive, so we want. So it is something useful you can experience. What is that? Okay, right. Good, I'm happy. So that is one thing. Say where you can tools and mathematical modeling. Our time we were doing all the things. Modeling was there to some extent, but mostly based on theoretically analyze and do. But now everything has to be modeled. Digital twin you would have heard, especially you are in AI. Every physical behavior has to be replicated and represented mathematically by means of equations. Differential equations will be there, partial differential equations will be there. These are the things which define the processes in the life, okay, in technology. So there, when you do the modeling and all those things, mathematical modeling, data science is nothing but mathematical modeling. Lot of this will be statistics and that feeding the data into the things. So how to represent this amplifier itself is there. If you want to model it, there will be so many parameters. So how you are going to do? A movie success itself is there. Nowadays, I think you will be aware, people can predict before itself how much collection a particular movie will make. You know that, no? You are all in data science. No or not? Yes. So, if this Prabhas hero, it will be something. Prakash Rao hero, zero. So, immediately we need not listen to any other parameter. Okay. Prabhas means 50% assured. Prakash Rao, zero, irrespective of whatever other things. So, it doesn't matter. So, but modeling, then you see when you are releasing the picture, is it Dasara time or is it Sankranti time? That's why. Or what are the other movies getting released along with this? So, like this modeling is happening. This when you give it a equation and mathematical form, it becomes a mathematical. Like a simple example, if you want to take also how much time it takes to cook, say, rice. It can be modeled depending on the type of heat, how much heat is getting wasted, what is the container, whether it is aluminum, stainless steel, or it is proper. So depending on that, and how is the ambient weather. So there are so many parameters, all of them you put in and fit an analytical model. So that is where and knowledge of latest concepts, because you are fresh from college, you will be having a very good knowledge about the systems. And fearlessness. See, we are all having fear. Earlier, elder people know with experience. Experience brings fear. Whereas youngsters, they don't have it. That's why if you go to Jawan operations, you are earlier all found with the Chakra and all, if you take, who are the awardees of power with the Chakra and all? Not some 60-year-old general and all. 20, 21-year-old major captain. Just they are fresh in nothing there. Because they are not afraid of this anything. They are simply ready to jump. So, same way you also, you will not fear what will happen in case we do this. Okay? So, you are ready to experiment. So, that fearlessness, that is what we need. And eagerness to experiment. You want to try something new. You want to experiment and say, we are all digital. No? But you are having that. This one. And unbelievable enthusiasm is there with you. And quick bonding with people unknown people. If any new person comes, you can strike friendship in 2 minutes. Even if they are unknown, any place they have come from, you are able to ready to strike a friendship. Same thing is not go at as you are growing elder now. It becomes so. That way teamwork, then people come together, you can work better. So these are all the things where you can make difference. And you will find discomfort also. It's not that everything is beautiful at the moment. There are issues where you will find. Or you feel that you get some excitement and feel that I found a great idea. You go and tell your boss. He will tell the boss this will not work. Okay? Then immediately you get to you will not be that is one thing. Because of reasons, because nobody wants to disturb a working system, even if idea is new. Because it may unsettle, especially in space. If things are working, we will never disturb them. Because something is working, why you want to disturb? So idea may not be as you may think it is a great idea. It may not be that great idea. Okay, that is always possible. No? We think ourselves great. And implementation issues. Even if idea is good also, to implement in an existing system to change, it has so many implications. Right? So qualification, tools and resources, money, people, priority of the organization, all those things. Because of that, your ideas are not yet immediate. And long gestation time to implement your idea. And procedural delays in procurement. What if you want something now, you can go and buy. In an organization, when you want to buy, there are so many procedures. Some committee will be there to review. They have to see. Then we are having something called need aspect committee. So they will require first review why the need is there for this change. Why you want to? Then finance committee has to go. Then some budget, whether money is there or not. Then final approval. Like that, there are so many stages. If it is a design change you are proposing, design review committees will be there. All those things. And procedural delays, yeah. Number of reviews. Okay. Reviews is another thing. You will understand it better when you go. But anything is there. There will be so many committees in space and we do know. So many committees will review. Then only because they will see and they have to tell, okay, I think I'll get some other place. And differences amongst your seniors. Sometimes in the house itself, if your mom and dad are fighting, you will be not so happy. No? Whenever they are doing. It happens everywhere. My children also think when I fight with my wife or my otherwise. That is always there. But seniors, when they gossip against each other, you will feel very bad. Correct? So you don't know whose side. You should never take sides. Just as though you are not listening, you should go. Okay? You should act as though you are not listening if they are fighting. Okay? Let them fight. So seniors, that differences also will unsettle you, but you have to. And gossip among seniors about some people will talk negative things. So never get those things discovered. And ISRO, the culture is many people ask us, so let's like in between it came, but why ISRO projects are successful among government? No? First of all, there are many departments where equivalent success is there in government also. Like railway, postal department, they are doing excellent service. But it's not because of the visibility and the beauty with which the rocket engine goes, everybody gets attracted. But otherwise, yeah. But mainly we can do it spirit. If the chairman says this project has to be done, no one says that it cannot be done or it is not. First itself will jump that we can do it. That spirit is important. Celebrate each other's success. Our own success we enjoy anyway. If I get first rank, I will be happy, I will celebrate. But she gets first rank, you have to celebrate. So that is something which brings the team together. So that is the spirit of it. So rise to the occasion. When required, you have to get up to the team. And openness. Very, very important that you should be able to tell what you want to tell in front of all. Okay? There should not be any worry that in front of chairman, how a newcomer can tell. There is nothing like that. Anybody can tell his idea, or if they are having a difference of opinion, they can tell. But openness is there. Then no hierarchy in technical assessments. Nothing like who is senior, junior, and if technically somebody has the right point, it will be heard. And committing mode of working, excellent review system, teamwork, personal sacrifice. We have to sacrifice because launches you would have seen. Sometimes in New Year night it will be their launch. Whole world is celebrating New Year and you have to be there at Park Center night, counting 10, 9, 8, 0, 7, all that. Okay, so at that time your family will be considering, you are not at home, all are celebrating and you are not there at home, like that. That is one, that sometimes very, very important personal issues may be there at home, but if launch is there, you have to go. That's all. So personal sacrifice is there. And the very talent base, as I told you, various different talents have to work together. And we are a family. All will work like a family. That is the thing. And okay, so we have got some various technical associations. Technology day we do, science day we do for school students, and we organize events. Some of you might have seen also. We have various professional associations like Astronautical Society of India, finance, space officers of the INSAM, welfare association, where somebody will come, Sardaji will come and do whatever dance on stage on welfare. Okay. And he will go back and do the extra inspection of the collector or that. So both we will do with equal ease. Hindi we must do Rajaswar, Kannada Rajaswar. And Grand Slam, we have a cricket component, competition for ourselves. Sports, even retirement functions at ISRO, you should see they are so grand and beautiful. And the photography, trekking people are there. There are trekking associations within ISRO. So you must be wondering, is there a nice life at ISRO? Nothing. You have to keep fun and this only. Are we amateur radio clubs and all there? With all this, we also make satellites. Okay? Like Tata Steel says, no, we also make steel. Okay, like telephone also nowadays. Nowadays you can also make phone calls. So we do all other things, but we also make satellites. Okay, now field of work. Everybody wants to work in design analysis. This was not because everyone tells you design is everything. But that's what you feel. It's not so. Because system needs all kinds of people. In an organization, we need everybody. Okay. So design, analysis, fabrication is an important field. Okay. Test and evaluation. What is fabricated has to be tested and evaluated. So that's another field. Product assurance. How to ensure this works. Facilities. For all this, if you want to test, you have to run a vibration test facility or thermal vacuum test facility or even your own computer lab is there. That is a facility. All these facilities have to be done. They have to be supported with, say, engineering support, MBS, they call engineering service, all that. Project management, program planning, like this. Organization needs all the people. So whenever you go, everybody cannot be put in design and analysis. But it doesn't matter what is that. Wherever you go, you should be able to contribute. Like I told Jayaprakash, no? He was there PM only, but he wanted to do that job perfectly. So you should be able to do that. All functions are equally important to realize the overall organization's objectives. Initially, you may feel peer pressure. My own example, when I joined, I was given to quality assurance. Just I came up, my friend was there who is 1 year before he joined me. He has there report. Okay, I am QA. Oh, QA, no. Okay, Papa, I get problem. But good, you are not in program planning like that. So, like that, they will show. Some people will tell because of the pressure. Oh, you are not in design, means although heavens have fallen, nothing will happen. Finally, after 5-10 years, the design phenomenon is there only. You can become. See, I was with QA background, but I was to become director. So, like that, it is always possible. But what is important is you have to bring dedication to whatever you are doing. In the long run, it really doesn't matter. So we know itself get prepared that whatever be the area of work, you will continue your best. So if you always do what you always did, you will always get what you always got. Okay? So if you don't want any change, you want to be very cozy and this one, then the result also. That is where people are talking about innovation. No? Innovation nowadays the buzzword is improvement and continuous improvement and innovation. So you have to do something different. That is what keeps the market going. So in any field there is good scope for innovation. And more freedom in ground systems compared to a rocket. In rocket, if I want to change, it needs to be cleared by so many committees. Same thing on a test system, if I want to do on the ground, I will have more freedom. That is there. But test systems often use more advanced concepts, devices, tools. You can always, but irrespective of that, you can always try to improvise the things. It could be automation and testing, logging, presentation of test results, how you present. Person to person, you can change, you can bring in innovation. Facility operations, tracking of project progress, how you do it using policy, all those. Use of analytical tools, data compilation. What is needed is sense of belonging. First thing is you should feel it's my job. Once you feel that, rest will follow. Urge to excel. You want to do it like nobody else has done. You want to do your job like nobody else can do. That feeling should be there. New ideas, dedicated efforts, good work is always recognized and appreciated. It gives you a sense of fulfillment and you can make a difference. So don't worry about the field of work. So to prepare for your new job, when you have 2 years only, so what you have to do is identify the technical skills required. Depending on where you are placed, you have to identify what is it that you have to learn something new apart from what you have learned in college. So you have to prepare. You have to find out subject knowledge associated with literature. Go to library. Nowadays, library everything is in your phone, but still there will be many things. And tools will be there, like I told you, piece-wise, ideas, national, matter, unique graphics, team center, all are mentioned in ChatGPT now. But we should know prompting how to do prompting engineering. Design rules are there, supporting disciplines, so many people there, like electronics, if you are there, PCB, there, if you are a mechanical person, fabrication, electrical, mechanical. Key people who can help you, you should be able to find out. You should be able to find out whom you can take care of. Some facts, no pains, no gains. This is universal truth, like it be in college or job, at home, anywhere. A person who puts effort only will get rewarded. Okay? And everyone feels they deserve the best. You can see the picture here. The cat is thinking with a lion. No? Everybody feels that I am the okay. I should get this because you may not be what you are thinking you are. that much realization is there, jealousy will not be there. If you have no jealousy and no comparison, you are happy for life. Okay, but it will never happen. So we are unhappy for our life. So this is one thing. Okay, at this age, you should have ambition is different. Ambition is mine. You should try. You should put efforts, but don't you be see that how to improve myself and get. Don't see how to teach other fellow. Like in the 3 years of he wants to see that other fellow is not doing. Or we had one friend, Sharat Chandra. Okay, he is not here, so I can tell him. So he will come. He will come to your room, talk to you, not his room, his room, his room. All rooms he will go. Till 12 o'clock, he will spoil all others' time. 12 o'clock, he will go to his room, and all these people will sleep, and he will start reading. Okay. So that is not good. So you please, okay, everyone, yeah, there we are. So you have to see that you are doing your job and don't feel bad about it. Don't feel jealous about others. If they have put effort, they will get results. Right? So you have to understand that and you have to compete. You have to compete. You should not beat. And the other things the most important is, especially your college, whatever initiative, I have seen your communication skills are good. I think oral, written, listening, presentation. When communication is a two-way process, most of them may speak well, but it is very difficult to listen to others. For us, no, like that, first you listen. Listening is a very, very important skill. Unless you listen, if you are not ready to listen, okay, then you cannot improve. So first you should be able to listen. Like the backbenchers, no, they are not able to listen. That's why whoever is having less listening skills are there in the behind. They should be the front actually. Okay. So listening is an important skill. Oral writing skill is very important. Nowadays, thanks to SMS language, we have forgotten how to write English full sentence. Huh? Everything will be one word or only, or even that we don't want right. For everything there is a short activation. Sometimes I don't know what it means. I will go and ask my children, what does it mean? Or I type here and see what does it mean. So that is okay for informal communication. But in technical, when you are doing formal communication is very, very important. So you have to improve your writing skills, listening, presentation skills. How you make a presentation, how to make a PowerPoint. That's also much I does. But there is a difference in a human does and in a machine does. Okay. That will organize things better for you. But you should think and think how to presentation and statistical tools, physical health. Never ignore your physical health. Okay. Physical health is another important aspect, and emotional maturity. In the today's generation, emotional maturity is little less. So we get immediately hurt. Even if mother says something, also you feel bad. Brother says something, you feel bad. But you should be able to absorb some amount of criticism, okay, or some amount of failure, or you should be able to observe. And the perseverance. See this picture you see. This was after failure of one of the AS service technique. You can see the person here. Can you recognize? This is Dr. Sona, who was previous ISRO chairman. This one after failure of a launch vehicle second time. Previous ASLV failed, ASLV 1 and ASLV 2 both have failed. So second time when it failed, you can see the moon in the control room. How it is. See, he was later he became sharp director. Okay, steer product very near to you. Director, see their faces. So that is natural because there is a failure, so everyone is disappointed. At the same time, did they continue like that? Oh, like that, so there is not like no. Forget what hurt you, but never forget what it taught you. Learn from your failures. How to make it successful. Okay, that you have to see. That is what ISRO is all about. So we never get deterred by our failures. As it is happening, then learn from that mistake and improvise yourself. Then what happened? See, that all gloomy faces have turned. You know all these celebrations across India. These are what Chennai and see, after Chennai, the whole country has celebrated. If they have thought that after the second failure, everything is doomed and we cannot improve further, like that, if they have thought, these celebrations will not happen. So never allow any incident to let you go down. So documentation, this is another important aspect. Okay, documentation is very important. Whatever you do or read or you do the work, it has to be documented properly. So there are various documents they have to make. Why document has to be done? Because it is for recollection, reproduction, even equipment has to be produced again. It is only by means of drawings and things like that. Because results, reviews, research plans, and whenever, especially software, when you write a software without comments, it cannot be, you leave the job and go somewhere. Next person comes. So how he will start the work from there? So that is where documentation is very, very important. So here I am showing you one picture where a launch was postponed. Okay. Launch was postponed. Here you can see. Yeah. What you are seeing here is this is an Antonov aircraft which will carry not people but cargo aircraft. It is called. So the cargo aircraft, a complete like metro railway coach you can see, is getting transported here. So spacecrafts also, when we have to launch from other place, we carry it in cargo aircraft. So in the cargo aircraft, when it is coming here, so you can see some containers and all they will come. Here you can see this is our own spacecraft container, which is coming and we are lying here. So this is in Kuru. And this is inside of this aircraft, it will look like this. So we went for a launch. At that time, the spacecraft container of our co-passengers, that means whoever comes along with that shape has become something like this. It has become like this. Why it has become like this? Okay. So if you are not interested, you tell us, we will stop here. I also can go home. If you want, we will stop here. I can go home. Okay. I have not done all the way 4 hours test like that. Whatever interests you, technical you are not interested. Stories I am telling that also you are not interested. Jokes I am telling that also you are not interested. If you cannot attend for 5 minutes, attentively 5-10 minutes, what you will do? Okay. So here we went to a launch pad. So there when we went and unloaded our spacecraft, and that's afterwards, after a week, the co-passenger launch vehicle Ariane's when it will take 2 spacecraft together. Our spacecraft is 4 tons, that is 4,000 kg, and we are having a co-passenger which is 6,000 kg. So both have to fly together because Ariane can lift 10,000 kg. 10,000 kg into orbit it can put. Okay. So 10,000 kg into orbit if it can put, then what is the 2 hours have to go. We have gone next day on Japanese spacecraft has come. They brought it from that same crew when it comes now. When a spacecraft is transported, you should see the way it is transported. Even the moment it comes, along with the spacecraft that we call convoy, top helicopters will be going because of the importance. So no attack should be there. And in the front, battery tanks, whatever you see in orbit, okay, the battery tanks will be escorting the spacecraft cargo from airport to Kuru. Okay, IN airport to Kuru. So all that family, it came and the Japanese thing, then they came, they removed the cover. Beyond this, there was some tarpaulin. That when they removed, the spacecraft container became like this shape. Spacecraft container is in this hourglass shape. Why it happened? See, whenever you are traveling in a passenger aircraft, the whole passenger aircraft is pressurized. There is a pressure inside the cabin. So we are able to breathe. Otherwise, as you are going high, pressure will be coming down. So here what happens, as it goes up and down, pressure will be coming down and up. But for passenger aircraft, this pressure is always maintained there. But in cargo aircraft, because you want to lift the more things, human beings are not there. So the pressurization systems will not be there. So that the weight of the pressurization systems also is transferred to the amount of cargo that you can carry. Like a goods train versus our passenger train you take. Passenger train, if you take, seats are required, fans are required, toilets are required, all this. All of this makes it heavier. But same thing, goods train, nothing, no, only one dabba is required, that's all. Rest is all inside. so that more amount of cargo can be handled. So that's how it works. Then, but what happens here is because it is going up and coming down on the station, the aircraft, due to the pressure difference, the shape has become like this. If that is the case, all cargo aircraft containers should become like this. Okay, you have studied one experiment on Medward half blow like that. So where inside if you evacuate, you cannot pull the even horses, 10 horses this side, 10 horses this side. Cannot pull it because of the vacuum that is there and pressure difference. So then everything should happen. So what we do is we give something called breather valves here. Here. Some valves will be there, which will be opening and closing. Okay, to make the pressure equal inside and outside during various phases of flight. Because of that, it will be safe. Here, what happened is that breather valves are there also, but they have put a tarpaulin, which is tightly wrapped around this container. They should have removed it before loading it into the aircraft. They have not removed tarpaulin, that's all. With such small incidents, because of that, a spacecraft which counts or which accounts for some 1500 crores. 1500 crores worth of spacecraft has gone because of they have not removed tarpaulin before loading the aircraft. That's all. Mistake is so simple. Such a simple mistake can cause 1600 crores loss. Okay. So last minute untested improvements you should not do. And devil is in the detail. So anything you are doing, you have to go to the last detail and see what will happen due to this. Unless you pay attention to detail, you cannot succeed in life. Okay? Not spacecraft, especially space technology. Yeah. Because and other unlimited doctrines of space, if anything can go wrong, it will do so when not expected. One test is better than 1000 expert opinions. It's very important to test. And Vidya says in very pictures, film की success सिर्फ तीन चीज से होती है, entertainment and entertainment. Okay. So same way, I will tell you a project's timely realization. Success we cannot get. That depends on many factors. But a timely realization of any project happens only due to three things. Okay. Interface. Interface means two different things. Then they come together. For example, you take this tiles itself. You take. Okay, two granite tiles. Tile will never break in the middle normal. All problems starts when two tiles are joined. There only the problem. Door you take. Just you open the door. The sound will come. Where the sound will come? Near the hinge. Correct? The hinge is the one which is interfacing the door frame to the whatever the door frame and door itself. See, my mother is like goddess to me. My wife is like angel to me. Bring angel and goddess together. That is called interface problem. Okay. So both are independently good. Together they cannot work. Okay, that is the problem. So here systems also technically I am telling you. Technically also there are systems. If you are electronics, you will know output impedance, input impedance. If they are not matching, then the systems will not work. Independently they will be alright. So there are so many examples I will not tell, but technical, human and societal interface also. Tata Nano factory, Silguri they have opened. That was at that time $1,000 car. $1,000, nobody in the world thought you can make a car. Tata ventured to make it. Everything was good, but they had to run away from Silguri because the societal interface, the local population was same way Kudankulam plant, atomic power plant in Tamil Nadu. It was ready, everything is ready, we have world-class technology. We are not able to start the operations because local people were protesting because of whatever concerns. So, societal interface also has to be taken care. So, you should build good relationships and interfaces. Another important part in life is to be honest. Our simple truth, suppose I am carrying a baggage which is going to be used in Banana, I dropped it. Nobody is there. I am bringing, I dropped it. Then, if you just put 2 crores package, 2 crores worth I am handling, I drop. Then I am doing it, connecting and testing. It is working. It is working. Now should I tell or not tell? If I tell 2 crores saying I have dropped, my boss will take. But you assume I have not told. It is working now, so no one knows. You assume I have not told. Tomorrow it is used in some very critical condition like Shandaya or anything like that. While coming back and dropping, if the whole of India is waiting, that time something failed and it did not land. I know that this failure was due to the package which I dropped. It was working that time, but afterwards, with some time later, you also you keep now. Today it may not, after 6 months also it will fail now. Sometimes it will happen. That is called carrying whatever that will be there. So if something has happened and it comes during say, or a person is returning from space to Earth, at that time some failure happened and that is person's died. You know that you have got the package and the death is due to that. Can we forgive ourselves in our life? Whole India's prestige is gone. No? Everybody, whole world is waiting. Recently, when so much understand that this one was there, helicopter over Mars, all of us were watching, though we have no direct connection. So that times, so it's very important to report problems. However, otherwise, if you tell at that time some analysis will be done, it requires some replacements will be done, you will migrate it and see there are methods to find out. But you have to be honest. It's not just for technical. Life also is always good to be honest to ourselves. Okay, Hippocrates is father of Western medicine. He belongs to 5th century BC. Okay, all medical graduates, engineering they don't do, but all medical graduates when they are passing out, they will be taking a test called Hippocratic work. Okay, so he is from 5th century BC. So in that he tells there are so many things which are told for doctors. So if I do not violate this road, may I enjoy life. So unless he says I should enjoy my life only if I am abiding by certain moral principles. And same thing for scientists. Okay, though we have come a long way, we still believe space will not forgive you if you make mistakes. Okay. So mistakes should not be done, and even if they are done, immediately we should correct them, test for the whole thing. And some general aspects for life are really ready to help and also seek help. Your password security. Today's world of social media, anything you leave your phone and do, I take that phone and do something from there, you are liable. Because it has gone from your thing or your mail account, your password you have broken, gone somewhere, I send someone that make something somebody. I am telling from experience, my own subordinates. She is daughter of a police inspector. Just to get that, somebody has sent some wrong message to some other person. Police came to our office because the other side complained. And we had to suspend their email account for a few months. Like that. So password don't reveal to anybody who are close to you. Because some terrorist message or some threat, you just tell this from your phone, I will send to ABC. One phone that one message that this aircraft is bombed inside. You will be questioned, not questioned, you will be jailed. Okay? So it's important that you keep your password secure in today's world of digital media, social media, and all that. These are all very, very small things. Till you face the problem, you will not know how much it will impact not you alone, your whole family will be destroyed. Okay? Okay. In Jammu and Kashmir, if one incident happens, the family itself is destroyed. Okay, people, security forces will go and demolish all this like that. So, keeping your social media, all these things, what you post, and the gender sensitivity, okay, because laws are there to protect minorities, women, okay, all these things. There are so many laws. If these laws are used against you, to prove that even if you have not done, to prove that you have not done itself will take its own time. Okay. All of you would have seen Proud and recent movie. Okay, they really happen, but otherwise also, yeah, like that. There are so many. This one, what's the movie name?
Logic.
Huh? Mahida. Mahida song I remember. Okay.
Ustad Bhagat Singh.
Leader. Okay, so right. Yeah. So the law is very, very tough. Law is very, very tough. So to come out to okay, here is shown other side, but there are other things. So never be on the wrong side of the law. Okay. Just if you tell someone by their caste name, you can be arrested. Okay. You should be sensitive to all this of the modern India, all these things. And punctuality, gender, social justice, okay. And we spend, especially if we are in government, whatever we are doing, we are spending public money. Okay. So we are liable for audit. We have to prove that we have been clean in our transactions. Office itself important. Now you are students, you make math, but it will very soon it will strike you, and afterwards you will have no other way to come out. So it's better to be aware of these things. Okay, this is normally I am doing the end of other things, but just quickly, just to have some. I have one poem here. While new joinees, afterwards I was just thinking how to start. I had some straight how to end my presentation. I was thinking that time my son was singing in bathroom. Oh mommy, please give me some vegetable soup to make me grow strong from head to my toe. C for carrot, B for beetroot, T for tomato too. Cook them all together and make me some soup. P for peas, B for beans, P for potato too. Cook them all together and make me some soup. Make it yummy, make it tasty, make it delicious too. I will think about all to the very last drop. You may be wondering, this man has come told us he tell about satellite something. No, Tevato is not only outside, but अंदर भी कुछ भी नहीं है. Okay, there is nothing inside us, so not only outside inside. I will explain. See here there is a customer, the child who is singing the song, and there is a supplier, that is the mummy, whoever is supposed to be the soup, and there is a product. You are all engineering people, so you should know product. The product is the soup here, and there are why the soup is being made. There is a functional, there is a mission goal. The goal is to make me grow strong from head to my toe. So from head to toe, you want to become strong. Okay? So that is the mission goal here. And we call something called preferred parts list in space technology. Only the parts which are figuring in preferred parts list have to be used. So that's why carrot, beetroot, tomato. Can you bring vision? No, it is not there in PPA. Same way they have declared materials list. Only materials which we are in declared and material list have to be used. Like peas, beans, right. And there is a different process. Just if you think process, painting of the wall, if you think, it has got so many layers of process. First, you have to prepare the surface. No, first they will clean. How to clean? There are different levels of sandpaper. Some 50 grade, 100 grade, or 20 grade, I don't remember no numbers. The painter will tell you what to clean. So with that, you have to clean. After preparation, you have to apply first a primer. Then again clean. Again, next step, again put one first coat. Then again clean. Second coat. Like that. So many things. There are various layers. Process. The process, anything that we do, we call some process identification document. It has to be prepared. How it has to be done. Soldering is simple. If you take how much time you have to keep, like that you have to take. And so here the process is specified. Cook them all together. You cannot do separate cooking because process is specified. And finally, my dear friends, there are functional specifications. Yummy, tasty, delicious. This is what the product is being made for. They are called functional. And the most important specification, my dear friends, is the reliability. I will think it apart to the very last drop. I was explaining you about various systems in spacecraft. So, in spacecraft, theoretically, the life is there as till the last drop of fuel is there. Even your car, if you keep driving, assume no petrol pump. Because we are not able to refill our spacecraft. So, when you are going to go through this, okay. So, how long you can drive till the last drop of fuel is there, assuming no other failure comes. Okay. So, we want our spacecraft to have till the last drop of fuel is there without any failure in other systems. For that to happen, everybody whoever is contributing to it have to do their food. So that's where people like you youngsters, whoever is joining, wherever, whichever organization you join, you guys try to see that you contribute your best irrespective of what is your goal. If you are writing a code, see that your code do not have a single bug. If you are testing a code, see that after your test, no residual errors are there. Or if you are manufacturing, okay, then your fabrication should be perfect. Like that, if you are designing the total structure, the design should not have any error. So with this kind of commitment, if you do the things, it will succeed. Okay. Next, I will go back to my original presentation.
Double 6851.
go back because I got in between something different. So coming back to remote sensing, we define what is remote sensing. So why, what are the advantages of remote sensing? Again, similar to whatever. So and there are various applications of remote sensing. Agriculture, crops, forest and bioresources. Okay. Then water resources, geology, ocean, coastal, environment, rural development, urban management. Like this, various applications are there for remote sensing. Then, whereas what is there in end-to-end if you take remote sensing, first there should be a source. The whole world runs around the sun. Okay. Prakash, Surya Prakash. My name is PJDKS Prakash Rao. No, Devendra, Koti Surya Prakash Rao. So one sun is running the whole world. I am Koti Surya. Okay. Yeah, there is a sun. Around sun, all the things, the energy from the sun is absorbed by Earth, and some of it is absorbed, some of it is reflected. Okay, it is reflected, and some cloud is there in between. It gets modified. That energy comes. Then atmosphere is there. It modifies the things. So from here it is reflected. That reflected energy is sensed by spacecraft. And accordingly, you will know what is there, whether it is a tank or whether it is an aircraft or whether it is something else. All these things are done by this. This is what are the remote sensing. So in different spectrums, in the electromagnetic spectrum, in say from 1 to 2 micron, it is something, 2 to 4 microns, something, from 6 to 8 microns, some other, like that. You will see if a crop is there, the vegetation. Depending on how it is coming, you can tell whether the crop is good or it is infested by some disease or if there are some killer, or pest. If the pest is there, all these you can sense from 500 kilometers above or 800 kilometers above the earth. You can tell what is happening to rice crop in Parana, whether it is giving good yield or it's so all these things are possible because of the remote sensing. Okay. So basically there is a source, transmission of energy from source to object, and this object, like a leaf spider, how it absorbs or reflects the energy, and that energy, reflected energy, has to be sensed by sensor and the spacecraft, which is 800 kilometers away or 600 kilometers away. Then scattering, absorption by atmosphere. In between it is not straight. Atmosphere takes something. All that you have to model. Detection, measurement, and output by sensor. Then you have to analyze the data and say what disease the crop is having. So if in agriculture, if you take one of the application is crop acreage and production estimation. See, for a country, you have to plan whether you have to import rice or not. Sometimes you see onion is not there. Suddenly from to tomato, cola they are throwing on the roads. Lorries loads of tomato. So how do they estimate whether you have to import? And then government controls. They will tell sugar no export. They will tell, or sugar no import, or anything like that. So they are going to estimate the yield that is going to come in the sugarcane field. How you can do it by sitting in Delhi? Is it possible for anybody to go to all the fields and measure and calculate? Not possible. From a satellite image, we are able to estimate the crop. How much rice is going to be produced in India this year? How much wheat is going to be produced in India this year? Like that, we can estimate. Then drought. Some areas we know that, especially Rajasthan, we are prone to droughts. Some areas are prone to droughts. So the drought, if you predict, you can take preemptive action. Government can take preventive action to supply some things or to cut down somewhere consumption and all that. Flooded area. When floods come, we don't know that so many acres are flooded. Therefore, we are getting, nobody is going there with the tape and everything. Some satellite imagery only we are able to gauge the extent of loss. But watershed prioritization, wherein fisheries, even in the ocean, where are the fish located? If a fisherman can go and simply put his net, but from satellite we can image and tell in a particular area fish something they have to eat. Whoever they will there, why around Bangladesh border and all population density is so much, industrial civilization and all, because there was so much of food is there. Like that, fish also go where food is there. So they eat particular type of algae. That algae where it is more we can sense from satellite. And we send messages to fishermen, today you go inside, fish will be more. They go and catch double the fish than what they would have done somewhere else. So these types of advantages and all are there, which are not known. People see only Chandrayaan and that. But day-to-day life, this will help you. Same way drinking water. We can say where the water takes more groundwater and all can be sensed from satellites. Forestry and biodiversity. See, Veerappa person, if he simply eradicating something or some, this one is happening. They are from satellite imagery you can do. So wastelands. In many of our things, we know that some of the, here to Tirupati to go itself, you will see some areas are not cultivated at all. There is nothing. Okay. So that wasteland mapping, how to do all that we can do. If you do that, if it is restored together, you should understand why that remained a wasteland. If you can restore the soil, sterility there and all, then you can produce additional wealth like crop, goods, timber, fuel. By analyzing that area, it can be done. So this is like disasters. I have already told enough. Integrated land and water resources. Finally, how we can use them together. Okay, and drought. Okay, nationwide waste and mapping. These are all fishing zones. This is called PF, potential fishing zone. See, where the normal catch is there here, and where we could identify potential fishing zone and waste, the fish catch is like this. Otherwise, it was like this over years. But as they improve, so you can see the catch is going down. So this is the electromagnetic spectrum, whatever I was telling. Okay, I can't go you all are engineers only, right from gamma rays to radio waves, in between visible, reflected, thermal IR, microwaves. So by sensing in different areas of this, by having different filters on the spacecraft camera, we can do it. So I think this. There are 4 types of resolutions. Resolution is how good you can see from satellite. How much spatial resolution is to make you understand. You can know that there is aircraft in one part. Otherwise, you can see sometimes on runway maps lines. That also you can read what is written on a runway. Okay, you can see. That is spatial. Spectral resolution, radiometric. I think I see. Temporal is how fast you can go see same place again.
Awesome.
What happens if satellite is not stable while imaging? The image can become like this. See, though it is a rectangle, because if satellite is not stable and if it is doing like this, then the image also will become like this. Then you will not be able to get correct numbers. Same way sometimes, if it is going like this, then the impact like this. If it is like this, the effect of the skew, all these things are there. So by doing corrections, you have to do because geometry, where it is there when we are determining, Earth is rotating by itself. Earth has some curvature, it's not a perfect sphere. Okay. Then at our attitude, I got spacecraft, how it is rotating. All these things will have corrections. They have to be corrected. You can see this is a very old picture, but you can see majestic in Bangalore. So many buses and all. Okay. Now anyway you go Google Maps, you will see all the names. Then science, I have already told about astrosat and all that, positioning and navigation. There is recently Delhi, all the flights were getting delayed because visibility is poor. You are not able to see. That is where to the GPS we aid with another satellite. Satellite augmentation system is there. SBS is called. Gagan system we are having. We have developed actually. It is integrated also, but it has to get ATC clearance also again. But all the aircraft have to be fitted with this equipment. Once they are done, you need not worry about visibility and all. Like a flying in this also, pilot can go ahead and all. In category 1 landing it is called. So these are all possible with satellite. So this is the integrated information. Satellite recovery mission, we went and came like this will be useful for future Gaganyaan missions and all. And what all spacecraft optimization when you are designing a spacecraft, most important is mass optimization. Because even if you call Bahubali, every entry can lift certain amount of it, 4.5 tons. That's all. Within that, you have to get so many functions. Okay. So that's why mass has to be optimized. Maximum utilization of cubic space. Because on space that you are having finally heat sheet, within that small volume, you have to put so much of function. Things which I have described, like the sensing from 500 kilometers, something on the ground, and all these things, how you are able to do. So for all that, cubic space has to be used. It has to work for a long time, and systems should be able to, and they should use less power. You know the best communication, the satellite, the remote sensing satellite, whichever I told, which is taking image on the Earth. Do you know how much power it consumes? It will be around 1 kilowatt or 800 watts. Your bathroom geyser takes 2 kilowatts, double the power of a satellite. A satellite which is able to connect to ground and give you information to 25 centimeters, that kind of resolution. It is able to detect the enemy tank on the ground from 800 kilometers. That kind of satellite consumes half of your bathroom geyser power. Half of bathroom geyser wattage, it can do all these functions. So you can imagine the amount of technology that is required to make this. Then an on-road autonomy, okay. State class has to live by itself. No, for 15 years it has to, that is. And cost, with all that, competition will make you to force to bring down the cost. So there are various payloads, as I told, communication, remote sensing, navigation, like that is called payload. But for all of them, structure is same only. Platform is same. Structure, mechanisms, so these are mechanical, geometrical, thermal, electrical systems, power. So this if you take structure, as I have told, for a spacecraft, if you take, this is how the structure looks. See, these are all the frames on which different systems will come and sit. I will show. So these are called the different, see, this is for 3000 kilo satellite. This is for 2000 kilo satellite structure looks like this. This is for 1000 kg, Carnosat, RXat, like this. But their job is to support all the, like a skeleton only. It can carry all the loads. Then thermal is to keep the spacecraft because sun is directly heating, whereas space is 4 degree Kelvin. So amongst this, inside systems have to be kept comfortable, 0 to 40 degrees. In the range has to be done. That is done by thermal system. For that, what you do if you go to Antarctica or somewhere, you will put a blanket, wool, something you will put it that is not sufficient, something more like that. Or if you go to some area, you put fan, AC, all these things. So we are conditioning ourselves for this. So thermal designer has to see that the spacecraft, whether it is the sun or space, it is still within comfortable temperature. Further, heaters are there to heat if required, and you are having some heat shields are there, temperature sensors, and this is MLI, multi-layer insulation. There are to keep it from cold, like that different designs have to be done. The mechanisms are the things like solar panels and all. When you launch it over, you see that two things will deploy. And that is generating power by absorbing sunlight. Earlier they are stowed together. They are kept together because the time volume in the rocket you cannot go like this now. Like this you cannot keep and launch because they all have to be accommodated within the heat sheet of the rocket. Then they have to deploy. When they have to deploy, space is so cold. At the time, these mechanisms have to work. And to all of you in the world, India is the only country where we have done around 500 onboard means after launch deployments successfully. We have done successful deployments, 500 plus. All other countries they have lost missions because their deployments have failed. But whereas we have done all our deployments have been successful. And whatever this you are seeing here, this antenna, whatever you are seeing, it is called alpha antenna. This is when you deploy, it will be looking like this room. Before that, it will be like umbrella. Okay, slightly bigger umbrella, like that, folded umbrella. From here to back to this size, you have to expand. What are the types of mechanisms? What is the, and they have to, and once deployed, it is there in 4 degree Kelvin. Okay, it has to work. That is the type of, like NISA when recently was launched was 7 kilometer. Then pyrotechnic devices, these are the ones which have to separations and all. No? For that some explosives they are basically. Propulsion is the one which gives the thrust to spacecraft to go from one orbit to the other or to maintain the orbit and all. These are all engines. Okay, can be solid engine, liquid engine, or nowadays electric propulsion also is there. In propulsion system, we have tank which will have fuel, and there are people like army. So some systems will be there which carry this fuel, and to pump you need some pressure and so pressure and tanks will be there, pressure regulators, and finally it has to be expelled through a nozzle. So these kind of engines are there. So composite is see, this is like a fiber. It's a very thin fiber. But with that we make structures. Steel and all if you make they are very heavy. So composite with this fiber, the tanks are made which withstand 400 times the atmospheric pressure. 400 bar. Anything if it explodes, this room will go. That kind of pressure this fiber can handle. Okay. With that pressure and tanks and they are called composite materials. They are the upcoming things. Even in cars, motorbikes, now you see very lightweight cars and all are coming. Mileage will improve. That is because of this composite material. So these are all elements. This is the tank, pressure and tank, 400 bar to 800 bar you can take. This is made of the fiber. Then power system, three things are there. One is solar panels to generate power. Batteries have to, because when sun is not there, somebody has to give power. That time battery is charged and kept, and rest of the time power electrons to distribute this generated power, condition and distribute power. So these are all different types of batteries. Then digital systems, okay. Anyway, you are not electronics people, but they are required, okay, for various things, like if you see in cockpit or dashboard, all the systems have to be digital. Systems have to be there. And communication systems, apart from that, like ground antennas, on board also, signal has to come down. For that, communication systems are developed. Control system. So this is in itself like a CPU, okay. This is the one which controls all, like our brain. So equivalent to that. So that will tell in that sensors are there, actuators are there, all and electronics. The brain is here. Okay, all of them have to do. And to keep the spacecraft stable, because it should not go like this, it should not go like this. So for all that kind of control, this is used. Here you can see all kinds of wheels and how they are. They will be running at 5,000 rotations per minute. Inside this, there is a 10 kg or 20 kg wheel weight that will be rotating at 5,000 rotations per minute. In 1 minute, it rotates 5,000 times, and it will be running like that for 15 years without stopping. Fan you switch on for 1 week without switching off, sound will come. Correct? So, but here no such thing. It has to work for 15 years like that. And these are the slip rings. 20 kilowatts of power. Your either is 2 kilowatt, I wrote. For communication satellites, they are there. 20 kilowatts of power, it has to transmit from, it has to transfer from outside solar panel to inside spacecraft. There will be working like that. So these are all various elements. This is the solar drive assembly. These are our wheels. So pressure valves. Mechanical wise structure I have told, thermal I have told. And design engineering and verification is another important aspect. These are all various mathematical modeling I have told you. So this is called the finite element model. Okay. So where these spacecraft structures and all are analyzed, FOV, field of view studies, charge model. Satellites when they launch, they will be accumulating charge. So that has to be studied. Then all these independent subsystems have to be brought together. They have to be assembled together. That is assembly integration. You have to bring them together and make it work. That is testing. Yeah. So in that again, where to keep which package, all those aspects have to be done.
అదే కాదు
Electrical, mechanical, environmental, all these aspects have to be studied and they have to be assembled together. And this is how a satellite inside looks. This inside picture, all of them are some 8 plus 8, 16 payload transponders are here. They are all assembled together. And the wire bunches which carry, the length of this wire will be running into hundreds of kilometers. If you take spread and put it in a line. And all these elements, this is just representation, this is actual. So all of them have to be kept together. So here, the spacecraft itself has to be transported in a container. This container design is important, and fixtures. While doing satellite has to be testing, assembly and all, you have to build, bend, turn. All these fixtures are here. Then satellite handling. How do you lift the satellite? See, crane is there, hooking. These are the fixtures. They are all there, and satellite on SPO. And checking out the satellite. Satellite has to be tested. For testing, we need some checkout equipment. Okay, all these equipment are. So this is actually integration of so many fields of engineering together. And these are the clean rooms where satellites are assembled. So you can see here, this is a big clean room where satellite. This picture is to simulate 0G because actual case 0G is there. You want to deploy solar panels here. The 0G has to be done here. Mechanical testing, acoustic testing, thermal vacuum chambers, mass properties, all these different sources. So explain what you do. If you just explore the satellite and see inside, this is how it looks. This is the structure. These are the equipment panels inside which all equipment are mounted, payloads and models. This is a battery panel. Battery is mounted. These are solar panels, power. Okay, these are called reflectors where payload is transmitted, and tanks. These are all propulsion elements are here. Fuel tank, EV panel, all of them. Future modular bus satellite views. This is how it looks. Okay. And launch vehicle. On which vehicle we are going to launch also plays an important role. So launch vehicle interface is something we have to work for. Mechanical, electrical, and radio interfaces. So all these things are studied. Then quality. How do you ensure that the spacecraft works for 15 years? In that we have to control every part that goes into spacecraft. Every single IC that goes into spacecraft is tested. Okay, design has to be assured, tested, software. So parts control. As you can see here, see, it could be resistors. Some ICs are here. These are some hybrids, transistors, power transistors, MOSFETs. All the devices have to be selected based on selection, quality level, component screening, non-standard components, radiation effects, reliability, failure analysis. All these activities have to be done for them. And every part, one single IC if you take, this goes through so much of testing. Recap, that means before sealing the device, there is a visual inspection, then sealing, then high temperature at 175 degrees centigrade. It is put for 48 hours. Temperature cycling, constant acceleration at 20,000 G. It is accelerated. Then particle impact, like this serialization, external, not ended. Still so many. Every single part goes through so much of testing. That's why it becomes expensive. Because you want to work it for 15 years without fail. Okay. That's the problem. Same time materials, it could be nut, bolt, fiber, anything, polymers, everything has to be done through all these tests. And if it is a metal, all these tests are to be done. Okay. vacuum stability, radiation withstanding, corrosion, fatigue, tensile, composite, like that, modulus, every material property has to be evaluated. If it is polymeric or organic, that is chemical materials, then other parameters have to be tested. Then reliability is to estimate, control, and manage the probability of failures. We are saying manage the probability, no elimination, because we are human. Whatever we do, right? So we want to manage the failures. Further, design principles, assessment tools, and statistically based sample testing. We do various analysis called fault stress derating analysis, failure mode effects analysis, fault tree analysis, trend analysis, weak circuit, worst case, all these. So testing and evaluation we have to do for various things. Workmanship defects, reliability, all that. Process, like I told, parts, materials, processes also have to be controlled. So people have to be trained to do each work and audit of fabrication facilities. And if we are getting it done outside, that vendor also we have to control. So every process that is to go has to go through so much of process for certification and so-called qualification. If you take for example one simple printed wiring board, in order to get qualified for using space technology, it has to go through so much. We do 10 boards, one group, 9 boards are tested for so many. Preconditioning, cleaning, visual examination, go and twist it. Try to twist the board and see what will happen. I see like that. Then they will, after passing, they have to go to group 2, 3, 4, 5, 6, where different tests are done. Same like group 7, one board will come here. So when all these things pass on, that particular company is cleared for making PCBs for space application. Okay, there are various models that we do, like engineering model, thermal model, all those things. So that's what we do here. And they have to go through a lot of series of tests. And this is temperature testing, where you test at lower temperature, higher temperature, and up and down, like the number of cycles you test. And integrated spacecraft also has to be tested for so many tests. Then this is spacecraft. This is a very cumbersome and very expensive test. Every day we do the test on spacecraft. It will be added to few lakhs. Towards the end of the test, the spacecraft is richer by few crores because the test would have, and 24/7, always some 100 or 200 people will be monitoring the spacecraft during this test. No matter whatever we may tell, still there are limitations. Everything cannot be tested on ground. That has to be complemented by analysis and other things. Okay, this I can explain, but so derating is something where if a part is there for 1 kilo, say 1 watt resistor, 500 milliwatts only, so that its life is extended. Like Shoaib Akhtar, if you know, Pakistani bowler, no? He will come and bowl like this. He can bowl at 160 kilometers like that. 2-3 matches he will bowl, then retire because he has always good energy. McGrath also can do that, but he will not do that. He will do 140, 150, one ball 160. So he will not get retired. So in order to have longer life, don't use your full potential. You slightly reduce your capability and you operate it, then you will live for longer life. Don't burn out yourself. So don't burn out yourself. Don't always operate at maximum stress levels. Slightly you reduce the stress level and work. In our life also gets extended. Okay. So like resistor means 1 volt. Capacitors are rated by their voltage. 100 volts capacitor used for 50 volts, like that. There are various guidelines, documents, which they will do that. And these are our documents where we will do so many documents have to be prepared for each system. Okay, worst case circuit analysis is something where I give example only. Just I want to catch a flight, you assume. I want to catch a flight from Google Maps, I will see how much time it takes. It is showing 1.5 hours from my house. Then I think there are 20 signals on the way. If all signals turn red, what will happen? 20 to 40 minutes you have to add. When you think on the way if light gets burst, then you have to change the taxi, you go to another, so you have to add another 20 minutes for changing. Suppose traffic police stops your vehicle and come aside, show papers, another 10 minutes. Okay. So like this, you keep on adding. Rains, Bangalore rain, that's all gone. So what we will do? So worst case analysis, what we do? We assume that on a given day, all the signals will turn red, police will catch, tire will get burst, rain will come all on the same day. Then when you have to start? You have to start some 6 hours or 8 hours before. Do we do that always? If I have to catch a flight for my friend's marriage, I will not think all this. Okay, like that. If it is for my own marriage, then I will start 6 hours before because I want to be more. So that is depending on criticality, you have to tailor your processes. This worst case circuit analysis does that on circuits. On electronic circuits, we do all this. Operating environment, effect of temperature, pressure, tolerance, aging, thermal drift, radiation, EMI. Like this, all these things we try to, and there are statistical methods. Every time we cannot go by worst case addition. Then it becomes only, it's not realizable design. Then we do some statistical things like Monte Carlo is the best method, where you try to impose different conditions in a statistical way and then try to design a system. Okay, here you can see in a code for some launch vehicle, in a code of few hundreds of lines, there was one line error, just one line error in hundreds or thousands of lines of code. You can see the impact in the background. The launch vehicle exploded. Just one line in thousands of code as an example. So that is the power of software. Its only name is soft, that's all. Only name is soft. It's not at all soft, the software. Software can keep. Okay. So there are so many examples. And the lesson will repeat itself until learned. You have to learn, otherwise, this is one more vehicle. You have not spent 500 crores to see Deepavali like this. Correct? This will be available for 1,000 rupees Chinese target if you buy. You can have this fireworks. You need not spend 500 or 600 crores. So we lost the PSLV like the first one, and Arrange Space lost their first vehicle like this because of software error. If that error is not there, either them or us would have become first agency in the world to succeed in their first attempt for launch. Because of one line software code error, both of us have lost our chance and hundreds of crores were lost. So that is the power of software. So don't ignore software. Software, there are so many ways to achieve software assurance. There is a third, there are so many life cycle models, waterfall model. So software requirements review, design review, test and evaluation, code walkthrough, non-conformance control, configuration management, all of these have to be done. This I will skip, I think, speak circuit and reviews. I told you I'll give one example. Once I attended a project management practitioner conference. In that, Ratan Tata, Mukesh Ambani and all, when they were younger, okay, they made the presentations when they were younger. So I attended in Chennai. Then one foreign university professor came, he made a presentation and has shown a video in which a record in a long high jump record was not beaten for a few decades. So many years the record was held like that. Then one person came and he went and jumped. Till then high jump they were jumping like this. This fellow came and jumped like this. Now common, no high jump they take their head first and do this. And he has beaten the existing record by few inches. A record which was not beaten for decades was beaten. So the punchline he says, if you want to reach higher heights, use your head, not your legs. Okay. So Here I am not saying these are very important. You would have seen as a, like if you have problem, you know it's that good. Not that way. But in a review, there are 10 people from different departments. Somebody brings a designer's perspective, somebody brings design perspective, somebody brings ergonomics, somebody else brings in visions perspective, somebody brings analysis, somebody brings a test perspective, planning, schedule, cost, like this, different people are sitting and analyzing. If one head can break a record of 10 years old, how when 10 heads are together and working for the same goal, what is the effectiveness that you can bring? So never be shy to present your work to others. It could be tomorrow your PhD thesis or your own dissertation as you are doing that. Don't think what this fellow knows, I worked all along. Nothing like that. It will be useful. Finally, when it is success, it is your product. So review is very useful thing. So it's good to have. So in ISCO, you ask any chairman, one of the reasons for our success we say is review system. Okay, James Webb Space Telescope I told okay already. So it has I will speak by him. So this is has found here the beauty of James Webb Space Telescope is whatever you are watching now is few thousands of light years old. That means what happened that time we are seeing now because light took that much energy, say signal has taken time to transmit this one. But from that we are trying to evolve how the universe has evolved. Yeah, now I tell about space ecosystem. All along, space means ISRO like that people were thinking, but now government wanted to enhance our output in the overall space economy. So that is why so many reforms are brought recently. Okay. So globally also, if you see earlier, governments used to dictate the space system. Now new space has evolved, and it is more worked out by private players. Elon Musk especially, he has changed the way space systems are working. So and space tourism is another upcoming business. So all of them have dictated to this. And in India, government has announced during COVID time, Nirmala Sitharaman, at that time, she has announced in May 2020 that private sector will be co-traveler. What is co-traveler? It will travel along with government agencies to see that space economy grows up. That's why you have seen recently Skyroot, Agnikul, all are nearby you only. So they are all coming into the private sector players are coming. And Prime Minister has told that there should be no space between common man and space technology. This is what so that's why ISRO facilities are available to you if you want to do something. You have to pay some nominal cost. Otherwise, the main problem is it's very expensive affair to set up. Each facility itself will cost hundreds of crores. So that common people, private sector cannot afford. So government has already established facilities in ISRO. Anybody can use by paying the operational costs. So here ISRO, NCL and in-space three mechanisms are there. Their works are given here. Okay, finally with all this, what we know is a drop. What we don't know is an ocean. Okay, this is told by Newton, Sir Isaac Newton. For me, he is the greatest. I consider him to be one of the greatest scientists. If he is telling this, we need not be proud of anything that we have done. You can be happy about it, but we need not go too much this one. Okay, so there is always good to have some modesty. Okay, then planetary platforms we have done, and then Chandrayaan little bit because without Chandrayaan people feel ISRO is not covered. Okay, so Indian first. But if you see history of lunar missions, there are different types of missions. One is flyby. That means just go around the moon like this and go flyby. Orbit or go around the moon. Third is impact. You go and hit the moon. You may not do anything but hit it. Then landing, or Chandrayaan 3 did recently land. And rover, from there you come out and roam around the moon. Okay. And then return is next. Go do all this and come back. That is one. And manned missions. These are all the things. And overall, if you take in the world, 60% is the success rate in moon missions. And Soviet Union, if you take 20 successful missions they have done, and have a number of lunar first, though people think America, first probe to impact the moon, first flyby, and image of lunar surface, everything was done by Soviet Union. Okay, first soft landing, first lunar orbiter, all of them are done by Russia. And two successful series of Soviet probes they are there. And but they also, if you see, first success after 5 missions. Out of in 7 years, 58 to 65, 2 out of 20 missions only successful. They attempted 20 missions, 2 were successful and 18 have failed. That shows you the complexity of these missions and also the tenacity with which they worked. 18 children die, he was you. Which parent will have time for this one to keep dying? But for the two successes, they are all 18 failures. Okay, so that is the collective national will. Ours means third failure, people will start criticizing, everybody will become a master in criticism. Okay, so that's what they have done. And 11 landing attempts failed. Russia tried to land 11 times, all 11 have failed. Okay, recently also along with us they also launched, that also failed. Before landing itself it failed. So that is the term. And US, if you take same 7 year period, first 14 missions failed. First 14 missions for lunar thing have failed. So they went on attempting. The 15th one was successful. 14th they allowed, but it was people also allowed it to fail. And the two of them partially successful. Next 3 impact missions were successful. 66 to 68, 5 were successful. And this is the only country to have manned missions to the moon. 24 astronauts have traveled. So 12 walked on the surface in 6 Apollo. Artemis will achieve. So once one interesting story is when one of the missions went, and then wherever whatever Neil Armstrong and Aldrin, they have landed successfully on the moon. Before the mission itself, Nixon had 2 speeches. He was the president. One to read if it is a success, one if they die. Both the messages were there. He has to choose which one you have because they were prepared for either scenario. So that is the risk associated with these missions. And China is recent times only they started. All the 6 are successful. Okay. So why it is so challenging lunar missions? Why? Same thing is not true for other missions. Why means because moon is at a distance of 3,84,400 kilometers times lunar injection and capture. To go and capture moon itself is very, very complex. And there is no atmosphere on moon. Ground when they are coming back, parachutes they will put and come. Moon doesn't have atmosphere like Earth. So parachute cannot be deployed. You have to do it engines only. That becomes very, very complicated control. So like this, there are so many reasons. So you can see these are statistics of moon missions. So Chandrayaan 1 and 2, Chandrayaan 1 first time itself we could successfully at least orbit around. Chandrayaan 2 also we all think that it is failed. What has not succeeded is the landing. But Chandrayaan 1 has a camera, okay, which is there. That is the best camera in the world to date. We have OHRC, optical high resolution camera. Even China, if they want to land something, if they want a picture of a particular area of moon, they approach India because we are having even US. If they want a particular area image, they come to India for it because we are having the best camera, and that was in Chandrayaan 2, which we are being failed and it was working for quite some time, 10, 15 years like that. So that is there. Lander as a portion, but orbiter we have the best camera in the world. We should be proud of that. And the Chandrayaan 3 anyway, you know. Chandrayaan 3 anyway, yeah. Because finally you all know its success and in matter. Okay, this is I think we'll break here. Yeah, we'll break here over. I think it's maybe over also. If you want, we can have 6 to 8 minutes. Yeah, you have to. engineering disciplines have to work together to make the systems. So that is the system engineering, and I'll just give you a brief introduction onto why it is. And
after them,
there is something called an International Council of Systems Engineering. So that defines a system as follows. First, what is system? System is a construct or collection of different elements that together produce results not obtainable by the elements alone. Any independent you take one, that alone will not give. But when you bring all of them together, like orchestra, if you take for example, just to good or just to vocal or just that will not give the final symphony. It has to be produced. There will be a conductor, there will be different instrumentalists, there will be a vocalist. Like that, when all of them combined, the net effect produced is where you call some of the individuals is more than any individual as a whole. So that is where the results improve system level qualities, properties. So system engineering is an interdisciplinary approach where different disciplines will work together. As you have seen, a spacecraft itself, if you take, there are so many things in the electrical systems, mechanical, thermal, deployments, all different things have to come together to produce one product, that is a spacecraft. So system engineering is first and foremost about getting the right design and then about maintaining and enhancing its technical integrity. Neither the world's greatest design may be beautiful, fully implemented, nor a poor design, brilliantly implemented. Either implementation or design, both of them independently being good around will not help. Both implementation and design and implementation, both have to be good to have a good system. So by and large, you should have the systems approach. It's not that you study system engineering as a subject or something. The approach is important, right? Because if you don't adopt total systems approach, it is the root of majority of problems. Design it and now fix later. Like that, it's not possible. While designing itself, you should bring all things together. And total life cycle considerations. What is life cycle? From the beginning of the concept of the product to its end, so till such time we should be able to plan and do the things. And requirements will be constantly changing. When you are developing a product, the requirements will keep on changing.
Meaning different.
And the more outsourcing, this is another reason. Nowadays, nothing is produced at one place. People will outsource and there are different things together and make a product. When you are doing that, and interoperability and globalization is international. Like I told James Webb Space Telescope, if you take, around 25 countries also have done it together. So various countries, they have to work together at different places. So there should be a common approach. That is the system engineering. So there are different types of systems. If you classify natural systems, okay. So and human-made system. We will talk about human-made, natural. We have no control. Only we should preserve it. That's all. Physical system and conceptual system. Then closed and open loop system. Closed loop system is relatively self-contained, like electrical circuit or chemical process. And open loop interact with the environment. So system of systems, which you call as a system, which is a subsystem. If you take from if you are a transport minister or something for the whole country, then or if you are taking total logistics in the country or something like that, power system, transportation system, communication system, all of them put together will come as infrastructure or something like that. But within that, if you take just power system for example, under power transportation system for example, you can have air transportation, you can have ground transportation, you can have marine transportation. So like that in the water, air, sea, and then on different places, different transportation things are there. But all of them belong transportation system. Now you come to just air transportation. Under air transportation system, again you can have systems like airport itself is a system, aircraft is a system, air traffic control is another system. So like that different things are there. And in aircraft, if you take airplane, whatever you are seeing as structure or propulsion, right down to crew, the people who are operating the aircraft, including the captain and the ground crew, all of them. So they are all forming another system. So like that, like that is a web. Everywhere you can take it independently like a system. Or in a larger system, this becomes a smaller system. Like that, subsystem. So main features is top down. You go from top and come down. And life cycle orientation. You want to see end to end. And the better and more complete effort towards initial identification. So you have to identify the beginning itself, not at the end. What are the systems that we need to do and interdisciplinary effort. Because the systems have to work in different systems. So most important aspects of system engineering are leadership. Whoever is leading the overall system, okay, so they have to be very good. They should focus on design and technical integrity and management of systems across various aspects. How do you manage them? And both have to be blended well. It is an art as well as a science. So life cycle, when you tell, one is the conceptual design, when you are thinking about the system, how it should be, and then comes the preliminary system design, initial phase, what you are making the system to be, and then production, design and development, then production of the system, then system operation, and finally retirement. System has to be taken out also, finally when it is going. So end to end, when you combine all of them, it becomes a system life cycle. So in that various reviews and all are there. So system engineering, what are the support disciplines? You cannot just like that. Suppose for example, I have shown you an aircraft where a metro coach was being transported. While designing the metro coach, you have to also think how to transport it. If you want to do business all over the world, it has to go in a, it should fit in a container. You develop some system which is not fitting in a transportable container. Then you have to make a special container for transporting the coach itself. That becomes too expensive and too much not realizable. So right from that, like that. So software, conventional engineering, reliability, maintainability, human factors and safety, ergonomics, environmental, disposability. Like batteries we are telling, now we are telling all electric cars. After some time, these batteries will become useless. So then how do you dispose them? Okay, that also you have to account now itself. Without planning now, if you simply produce, after some stage, like we are doing with plastic now, the stage will come when you will not know where to throw this unless you plan for it. Okay? So end to end, like retirement of the system, up till that has to be planned in the from the early stage itself. Same way logistics and supportability engineering. And as I told, if it cannot be, you make something which cannot be done in a transport truck use. Then sometimes turbine blades, if you have seen, I have seen from Chennai to Bangalore route. Big turbine blade will be there. It will be occupying so much of the road. Okay. So that time everything will be slowing down, all those things. So it is not possible in that case, it has to be a single piece, otherwise if you can break it down and transport. So all these aspects are design. Manufacturing and production. Engineering design may be very good. But when you go to the manufacturing, the scheme and everything is not possible to produce this. Okay. All of them have to be there, and software is one of the most important. Now there is nothing which is not there in software. So these are all various reviews I have told and various life cycle institute. So this is something called interfaces. How do you handle interfaces in system engineering? So these are all there, various experiments. So these are the engineering way of showing the interfaces. It is another important aspect which is called technology readiness level. If you are developing a new system, somebody else has to say adopt it or take that technology. There is something called technology readiness level. Where is that technology? And what is the level of maturity? It may be at the basic principles of it, that is called DRL1. DRL2 is technology concept is there. B is in lab, you have proven it works. 4 is that some type of small model you have done and you are able to prove up component and backward validation like this. Finally, if you are able to prove it in flight, that is called TR9. Okay. So these are all the things which will help investors to decide where is the maturity level of your product and to invest or not. So that is the one. So risk is another thing. Risk assessment is very important in system engineering. So we have to assess the risk as the system is progressing. And on system engineering, systems, even very large systems, are not developed by groups of system engineering, but only by engineers using the tools of systems engineering. So we should use the tools of system engineering. Tools should not use us. Okay. So you have to understand the physics behind each of the tool. Simply going to ChatGPT and trying to do is not correct. You have to use it because it simplifies your work. But the basic thing, how it is working and all the concept and all, we should control ChatGPT, not other. So what an system, ideal systems engineer, what he is supposed to be is, he should be able to define the problem. He has to work on various types of complex, integrated and multidisciplinary systems in different application domains, different applications. To communicate system engineering principles to others, solve, resolve or absorb the problem. So this capability should have, should understand fundamentals of mathematics, physics, and other pertinent sciences as well as capabilities of various people and disciplines. You should know the sciences, you should know the technology, you should know the people also. That is what a good system engineer is. Mastering at least one technical discipline. You should be good in one discipline at least and learn multiple. Everything you should know little, but one of them you should be perfect. Responsible for designs, technical integrity, and he must understand the final output. And what the characteristics of system engineering should have to curiosity, desire and ability to learn new things. So finally, you should appreciate the importance of the process, how to have a discipline and all those things. Rigor and knowledge of when to stop. You should know when and how to use will not be bored by them. Lack of process rigor leads to disaster, but too much can lead to rigor knowledge. Good engineering judgment is a lot of way. How you have to become good systems engineering means who is responsible for your own growth? Is it for college if I take your principal or your which head of department or your teacher? No. Answer is each person is responsible for his or her own development. Nobody can think your development. It is you who have to feel that I have to develop. Only your energy will make it reach higher heights. And many may be willing to coach mentor, but finally it's up to individual. They are their own professional development. I think component engineering is something where design, process, all the things will be happening together. Okay, so just I give you what is systems engineering so that if you are interested, you can further learn. But future is in systems engineering and multidisciplinary approach. Just focusing on one area in today's world, technological world, you cannot go much far. If you want to make a good progress, it is important to develop interdisciplinary skills. With this, I would like to close and thank you very much for your patience and impatience in work. Maximum clapping for closing. Okay, thank you.
జాకెట్ లేదు కదా జాకెట్ బ్లౌజ్
Chaitra to propose the vote of thanks and formally conclude today's program. Good evening, respected dignitaries, faculty members, and my dear friends. I take this opportunity to express my sincere gratitude to our esteemed resource person, Dr. Prakasha Rao Garu, PJVKS, resident expert in space, for delivering such an insightful and inspiring session. His valuable sharing of knowledge and experience on India's space journey, emerging opportunities, and quality assurance has truly enriched us all. I would like to extend my heartfelt thanks to our academic director, Dr. R. Sarvanan Garu, Dr. Surya Prabha ma'am, and the management of MTIT for their constant support, encouragement, and guidance in organizing this program. I also express my sincere thanks to our respected head of the Department of Artificial Intelligence and Data Science, Mr. K. Lokesh Garu, for his continuous support, motivation, and leadership in making this event successful. Once again, I thank our distinguished guests and all the dignitaries for their valuable time and support. Thank you all.